We've been talking about solutions, and the other day we introduced colligative properties. For example, boiling point elevation. We said the boiling point of a solution is greater than the boiling point of the solvent that was used to make the solution. And after the quiz yesterday, we started to introduce freezing point depression. We said that the freezing point of the solution is less than the freezing point of the solvent that was used to make the solution. And we talked about how the intermolecular forces have more difficulty forming when solute is dissolved in solvent, and why the temperature has to be even lower for the solution to freeze compared with the solvent. We also talked about why you salt roadways up north. It's not to melt the ice, but rather to lower the freezing point temperature so that it has to be even colder outside in order for the solution to freeze, and that makes for better driving conditions provided that it's not too cold. The other thing that we mentioned the other day was that there are two formulas that you will use to calculate the freezing point of the solution. And they look very similar to what you did for boiling point elevation. For freezing point depression, and this is in your notes, the first formula is delta TF is equal to KF times M times I, with the only difference here compared with the delta TB is that you will be using KF's mole-out freezing point constants, and we talked about this yesterday, that they are found in the last column on table 2 of your periodic table. So for example, and again we did this yesterday, if the solvent is water, the mole-out freezing point constant is 1.853 degrees Celsius kilograms per mole. If you had camphor, 37.7 degrees Celsius kilograms per mole. So this is your mole-out freezing point constant. Your freezing points of the solvents are indicated in this line here, or this column. Acetic acid freezes at 16.66 degrees Celsius. We know water freezes at 0 degrees Celsius. So the key difference, one key difference between freezing point depression and boiling point elevation is this first formula where you are using KF. What does the M represent? Molality, good. So that's moles of solute over kilograms of solvent. And I is? The number of particles, and that you determine from the solute. If you have a non-electrolyte, your I will be 1. If you have an electrolyte, an ionic compound that is soluble in water, you will dissociate it and figure out how many particles you have in solution. The second part to determine freezing point depression is that the freezing point of the solution is equal to the freezing point of the solvent, and we know the freezing point of the solution is depressed, so we're going to subtract delta TF from the freezing point of the solvent, resulting in a lower temperature for the freezing point of the solution compared to the freezing point of the solvent. Okay? And we'll walk through the first example, which is shown on your screen. In the first example, it says at what temperature will a sodium chromate solution freeze? So we're looking for the freezing point of the solution. We have 103 grams of sodium chromate, an ionic substance that's soluble in water because it starts with group 1. And we're going to dissolve it in 800 grams of water, my solvent. Let's get the information down and we'll work through the problem. So on number 1, we want to know the freezing point of the solution. The mass of the solute is 103 grams of sodium chromate. The mass of the solvent is 800 grams of water. First formula is that the change in freezing point is equal to Kf times m times I. Where do we get Kf from? Back of the periodic table, what's our solvent? Water, what's the Kf? Good, 1.853 degrees Celsius kilograms over moles. We need the molality. How are we going to get that? Exactly. We're going to convert this to moles first. Excuse me. But we don't plug moles in, we plug molality in. So what do we do with that? Good. And some of you had some difficulty on the quiz. You couldn't differentiate between molality and mole fraction. So that's something we're going to want to brush up on. And then the last part of the formula is I. Do we use the solute or solvent to figure out I? Solute. So you take the solute and you write a dissociation reaction. So you dissolve it in water to generate ions. And then you balance it. I is equal to the sum of the coefficient of ions. That's the number of particles. So I is and then the last part, to get the freezing point of the solution, it's the freezing point of the solvent, which is 0 degrees Celsius for water. If you had a different solvent, you'd look up its TF, and from that you will subtract the freezing point. You will subtract the delta TF, and now you have the freezing point of the solution. And when you dissolve substances in water, they will have a freezing point less than 0 degrees. That's why oranges, grapefruits, other types of fruits in the groves don't freeze at 0 degrees Celsius. They freeze at temperatures below 0 because they contain sugars, which are solutes. Now those sugars will have an I of 1 because they're covalent compounds, but depending on the concentration of sugar, the greater the concentration, the lower the freezing point. Yep.
Why is 4.42 3 sig figs?
1, 2, 3.
Yeah, why do you have it?
Because my molality was in 3 sig figs. I see what you're saying. This is not relevant for sig figs. The second question's grossly similar. Let's pull the information out. What are we asked to find? The freezing point of the solution. Good. What's the mass of the solute? Good. Highlighted in green is the mass of the solute, and 788 grams of phenol represents the mass of the solvent. Good. So we've got the information. We'll get it down, and then we're going to see if you can get it to rip. So on number 2, the freezing point of the solution. The mass of the solute. And what's the first thing that you will do? There's a number of places you actually can start. Let's get moles here. Be careful with acetates. They're sometimes difficult to add up. Now that's not molality though. What do we have to divide that by? Kilograms. And again, 3 to the left. That also was a little bit of an issue. Where do we get our KF from? And what's our solvent? Phenol. So our KF is? And how do we get the I? Solute or solvent? Solute. We've got barium ion and 2 acetate ions. So what's our I? Oh, you know what? I put the wrong molality in. I calculated it and then I rewrote it. Oopsie. I just shoved that back in. What molality did you get? That's what I got. So I wrote the division out here. I did it in my calculator, and for some reason I just flipped back to kilograms. So make sure that's correct. Okay, so my delta TF is 9.32 degrees Celsius. The moles cancel, the kilograms cancel. And again, this is your molality from dividing here. And then your freezing point of the solution, how do you calculate that? Which is what? And make sure you subtract because the freezing point gets depressed or lowered. And you have 31.58 degrees Celsius. That's the temperature at which the solution will freeze when you dissolve 84.5 grams of barium acetate in 788 grams of phenol. Say it again? No, because when you subtract, you go to the least number of decimal places. You maintain the 3 sig figs here. You have the 100th place in both instances, and you maintain that. When you add or subtract, you go to the least number of decimal places. So that's freezing point depression. You want to be able to calculate both boiling point elevation and freezing point depression. There are several other colligative properties such as vapor pressure depression, osmotic pressure. We're not going to get into those this year, so we're not going to be exploring either of these. I don't know in AP Bio anymore if they still do osmotic pressure calculations. If they do, it's really very simple. The other thing that we're going to be exploring is now that we know how to calculate the freezing point of the solution or the boiling point of the solution, from that information you actually can work backward and get the molar or molecular mass of a substance. Questions on freezing point depression? In your classwork, (15 through 19) deal with freezing point depression and boiling point elevation, and they will provide some very good problems for you to make sure you've mastered this concept. I do not anticipate a second quiz in solutions, so it's really important that you are able to calculate freezing points of solutions, boiling points of solutions. Make sure you're understanding it. You can do the classwork with ease because you won't be quizzed on it again. When we return from break, we've got a mini lab to do, a full-blown lab to do, some review, and then you'll be tested on the solution chapter. I've never before not gotten solutions in before break, so just be careful over break that you maintain your understanding of solutions. I'll get your quizzes back to you. Your class is graded. They're just not all entered yet because I have yet to complete the last group of kids who quizzed. Your grades are due at 3 p.m. tomorrow. I don't know when they're posting them school-wide. I will do my best to post them as soon as they're done so that you know. And again, this is the classwork that goes with the lessons on freezing point depression and boiling point elevation. This class may be slightly behind the other classes that will be going on to molar mass determination, but I'll catch you up over after break, so it won't be a problem. I filmed today, I'll post yours. I filmed 6th, and that's posted as well, so there'll be 2 postings for this, but you have everything very spelled out here. Questions?